Hello everyone, welcome to my channel. In my last lecture, I discussed about complex analysis. Today I discuss about Laplace transformation, which is important for entrance examination. So please see this video very carefully. So the Laplace transform takes a function of time t and transform it to a function of a complex variable s, where s referred to as a frequency domain. Transformation is invertible and no information is lost, and it is reasonable to think of a function of f of t and its Laplace transformation is capital F of s. As two views of the same phenomena, each view has its use and some features of the phenomena are easier to understand in one view or to the other. The Laplace transformation help in solving the differential equation with boundary rules without finding the general solution, and the values of it is arbitrary constant. So the major application of the Laplace transform is to solve high non-trivial differential equation, both ordinary and partial, by converting it into a algebraic equation, which in turn are easier to tackle. So the definition of a Laplace transformation is defined as: let f of t be a function of t for t greater than 0. Then the Laplace transformation of f of t denoted by Laplace transformation of f of t equal to capital F of s is defined by f of s equal to Laplace transform of f of t, which is equal to 0 to infinity e to the power minus st into f of t dt, where s is real or complex. Now let us complete the Laplace transformation of some elementary function. For example, suppose f of t is equal to 1. Now we calculate the Laplace transform of f of t equal to 1. So we know the Laplace transform of f of t, that means f of s is equal to 0 to infinity e to the power minus st f of t dt. So here we put f of t is equal to 1. So Laplace transformation of f of t, which is equal to 1, means 0 to infinity e to the power minus st into f of t value is 1 into dt. So if we differentiate it, we get e to the power minus st by minus s. If we put the limit 0 to infinity, we get the value of this is 1 by s, and you must remember s is greater than 0. So we can write that f of t, if f of t is equal to 1, then the Laplace transformation of f of t, which is equal to 1, is 1 by s for s greater than 0. In a similar way, we can find the Laplace transform for the following elementary function. So if f of t is equal to t, then the Laplace transform of f of t is equal to 1 by a square, and for f of t is equal to t to the power n, the Laplace transform of t to the power n equal to n factorial by s to the power n plus 1, and the Laplace transform of e to the power at equal to 1 by s minus a, and the Laplace transform of sin at equal to a divided by a square plus x square. Similarly, the Laplace transform of cos at equal to s by a square plus a square. Similarly, we can find the Laplace transform of sin hyperbolic at equal to a by a square minus a square, and cos hyperbolic at equal to s by a square minus a square. The Laplace transform of e to the power minus at, which is equal to 1 by s plus a. That rule is very important for entrance examination. So you remember this rule for calculating the Laplace transformation problem. Suppose one problem is given, find the Laplace transformation of 1 plus sin 2t. So we calculate the Laplace transformation of 1 plus sin 2t. Then how you calculate it? You separate it like that way, that we calculate Laplace transformation of 1, Laplace transformation of 1 plus Laplace transformation of sin 2t. So Laplace transformation of f of t is equal to 1, that we know the rule. If Laplace f of t is equal to 1, then Laplace transformation of 1 is 1 by s, and Laplace transformation of sin at is equal to, we know, a by a square plus a square, where a is 2, so we can write 2 divided by a square plus 2 square means 4. So Laplace transformation of 1 plus sin 2t, which is equal to 1 by s plus 2 by a square plus x square.